figure above shows a seesaw which is exactly in balance. The weight of the people sitting on it are 50 kilogram, X kilogram, and 15 kilogram as shown. They sit at a distance of 1.5 meter, 1.5 meter again, and 2 meter from the pivot respectively. What is the value of X? Now from this diagram, what we have are three different people sitting on a seesaw. Now this is with 50 kilogram sitting on this end, while weight X kilogram and 15 kilogram, mass X kilogram and 15 kilogram are sitting on the other end of the fulcrum. Now weight 50 kilogram is 1.5 meter away from the fulcrum, with X kilogram is 1.5 meter away from the fulcrum to the right, while weight mass 15 kilogram is 2 meter away from the fulcrum. What we're asked to find in this question is X, the value of X. Okay, now let's go. It is obvious that the masses X kilogram and 15 kilogram are the ones that cause the clockwise moment. They cause the clockwise moment, while the mass 50 kilogram causes the anti-clockwise moment. You can look at the diagram again, which is very important. You can see that these two masses, their weight will definitely push this end of the bar, this end of the seesaw downward, and if you follow the rotation of the seesaw in this regard, we can see it is going clockwise-ly. It's going clockwise-ly. It's going clockwise-ly in the direction of the clock. So we see these two masses cause clockwise moment. Now we come to the other end of the seesaw. We can see that the weight of this mass 50 kilogram will push the bar downward, and with respect to moment generated, we say it's causing anti-clockwise moment. It is causing anti-clockwise moment. So mass 50 kilogram has a weight that generates anti-clockwise moment on the seesaw here. Now we can now go back to continue our solution. We know that mass 15 kilogram is 2 meter from pivot. Mass X kilogram is 1.5 meter from pivot, and mass 50 kilogram is 1.5 meter from pivot as well. The next thing to do is to solve our problem is to invoke the principle of moment, which states that sum of anti-clockwise moments is equal to sum of clockwise moments about any given point. Sum of anti-clockwise moments is equal to sum of clockwise moments about any given point. Right. So let us calculate the sum of anti-clockwise moments and equate it to sum of what? Clockwise moments. We have that mass 15 kilogram is 2 meter from pivot. So, and mass X kilogram is also 1.5 meter from pivot. So mass 15 kilogram, the moment due to 15 kilogram is going to be 15 times 2. The moment due to X is going to be 1.5 times X. That's X times 1.5. While the moment due to 50 kilogram is going to be 50 times 1.5. Alright, so it means this is the anti-clockwise moment. Anti-clockwise moment is due to 50 kilogram. So it's going to be 50 times 1.5. Now, these two bodies generate clockwise moment. Mass 15 kilogram generate clockwise moment. Mass x kilogram also generate clockwise moment. So the sum of clockwise moment, as if 15 kilogram generates clockwise moment and x kilogram generates clockwise moment. So the sum of clockwise moment therefore is going to be 15 times 2 plus x times 1.5. Right. So we have sum of anticlockwise moment equal to sum of clockwise moment. Sum of anticlockwise moment to be equal to sum of clockwise moment. Then we evaluate 50 times 1.5 is 75. X times 1.5 is 1.5x. 15 times 2 is 30. So we have 75 to be equal to 1.5x plus 30. Now to find our x, we have 75 minus 30 equal to 1.5x, which means 45 is equal to 1.5x. So if we divide both sides by 1.5, we have x to be equal to 45 over 1.5, which is 30 kilogram. So mass x is therefore what? 30 kilogram. That's the calculation that we have done. Now let's come back and look at it again. The moment due to x is x times 1.5. The moment due to 15 is 15 times 2 meter. And these two, when you add them together, x times 1.5 plus 15 times 2 gives what we call clockwise moment. Then we'll come to the other side. The moment due to this 50 is 50 times 1.5 distance from fulcrum. The perpendicular distance between 50 and fulcrum is 1.5 meter, and that's the moment generated by 50 kilogram, which is 50 times 1.5. So this is anti-clockwise moment, 50 times 1.5. While clockwise moment is due to x and 15. So that's x times 1.5 plus 15 times 2. So you equate the sum of anti-clockwise moments and the sum of clockwise moments, alright, based on the principle of moment, and then that is what helps us to solve for x, right? So this is the sum of clockwise moments, and this is the sum of anti-clockwise moments. So when we equate them, we get our value of x, right? Please take good note of that, and can go over the video again if it is not clear. And if there is any question, please do not hesitate to let me know. Thank you very much for watching my video. I hope you learned something. Learn something that is worthwhile. If so, I will appreciate it if you just like the video, and you can go an extra mile by subscribing to my channel. I will also appreciate it. And then I would like to see you in my next video. Thank you very much.